Welcome to my channel, and this is my journey in math. And it's a story, and it's just also meant to be a learning experience. And I want to start off by explaining my background. That's what the purpose of this first video is, and then kind of explaining where we're going to go. So my journey in math started in 1978. And I'll just show my age there. 1978. I remember I was 3 years old, and I don't remember a lot of things when I was 3 years old, but I remember this when I was 3 years old. And my parents were teaching me how to read, and I learned how to read pretty early, and I learned how to do math pretty early. But in 1978, I was at my uncle Glenn's house, and they lived in Houston, and he handed me this calculator, and it was very, I still remember what it looked like. It was black. It was like this little calculator, but it had those, it didn't have it had like LED lights. It wasn't like any kind of calculator that you've seen today. I can't explain it, but the lights lit up. And I just remember asking my dad, hey, what does this do? What does this do? And what does this do? And it was fascinating, not only because it might have been one of the first early scientific calculators. I have no idea what kind of calculator it was to this day, but just the fact that it lit up and it did problems. I wanted to know what it did, and so that started my journey in math. I just wanted to know, well, what does this do? What does this do? What does this do? And I didn't even know anything about math. I wanted to know what it did. So supposedly, I'm 4 years old. I don't remember. I learned to add, I learned to subtract, I learned to multiply, because in kindergarten I was doing multiplication problems to the point where the teacher didn't know what to do with me. It was in kindergarten, and I was doing like 7th grade math. They gave me this book, and I still remember what it looked like. It was this big black book with like a gold front, and they were like, go in the corner and do some math. And I went in the corner and I did all my math while everybody else is dancing around with inflatable letter people and stuff and listening to Tom T. Hall. I like Tom T. Hall. Tom T. Hall is a big let me write his name down here. Tom T. Hall. Google him, listen to some of his music. That's good music right there for kindergarten. I think some of his songs are still around. Tom T. Hall. That's my kindergarten experience, is listening to Tom T. Hall and doing higher math. And then in 2nd grade, I acquired one of these, and it didn't look exactly like this, but all the buttons are the same. This is an archaic. This is a Ti-53. Mine was all black with gray keys, so everything was the same except it was all black, and of course the writing up above was right. And this was a calculator because it had this fancy this is how fancy this calculator was. It had store and reclaim, so you could type a number in, say 123, and you could hit store, and then anytime you ever wanted to use 123 again, you could hit reclaim. And that was just whoa. But it also had programmable. This is the programmable stuff that I never learned. And I said, Dad, what do all this stuff do? What does log do? And what does ln(x) do? And 1 over x, you can kind of figure that out. X squared. Here's cube root of x, square root of x. I mean, what do all these do? What do these buttons do? And he tried really hard, and then he pretty much gave up and let the teachers take over. But this is one of the first calculators that actually had parentheses on there. I'm not sure if this calculator understood the order of operations like a lot of modern calculators do, but the really cool thing about this was the fact that you could hit store and store. I mean, that was amazing. This is 1982 to 80. I had this calculator well into the 80, maybe 87 for a while. I had this calculator for a while. I still look at it, and then the inverse key did the inverse. So if you it kind of this is the square root key right here, and this is the x squared key. So this key kind of defeats the point of having two keys on there. But if you wanted to find the sine of a variable, say you wanted to find the sine, I don't know, sine of 45 degrees, and it would do degrees, and you could use this button here to change it to radians, because it has a pi key, right? So sine 45 will give you square root of 2 over 2, and then maybe you want to find the inverse sine. You could hit square root of 2 over 2, hit inverse, and it would give you 45 if you were degree mode, and it had this little thing up here that said degree, or it had radians. And I was 7 years old in '82 when this calculator came out, and my dad just, I don't know. So we had to figure it all out, right? So this was part of the journey. And then, I mean, the journey goes to where we are now, where we have calculators like you see on my right, like this calculator, the Ti-Nspire, and that's kind of what I'm going to talk about, where I'm going to get through. Look at this bad boy. I mean, it's color. It has almost all the same buttons. It's almost the same size. No, it's not. Yeah, it is. What was neat about this calculator, I had the version that this part you could actually fold up. This calculator doesn't have that, of course, but this one's in pure color. What I like about this calculator is that it has a rechargeable battery. You can plug it into the wall and recharge it. This is the first of the TIs that do that, and I'll go through some of the TIs that I've had over the years. And the alphabet, I don't need the entire alphabet. All I really want is XYZ. But I guess if this was a phone, there you go, people at TI that read this, if you could turn this into a phone, I wouldn't need this anymore. This is I have a Note 3, and it's almost as big as my Inspire. If Texas Instruments could just make some cell phones instead of just calculators, wow, you know. But they make great calculators, so don't get them wrong. They make the best calculators that are out there. And I've used the HP Hewlett-Packards, I've used the Casios, and in my experience, I don't endorse any of the equipment that I use except for this one, and it's been a constant ever since I was 7 years old, 1982. What's that, 2014, 1982? We're looking at 32 years. 32 years of using TI calculators, and I used this one until I was in 8th grade. In 8th grade, they started making what was the Ti-81, and it was the first graphic calculator, which is kind of like this, but not even near as fancy. And I was asked by my teacher, because bless her heart, she really kind of took advantage of me on this, but I suppose somebody would I was a teacher for a couple of years, and she was a teacher for many years, and her name, I don't even want to mention her name, because my friends that watch this, they know who she is. She wasn't the best teacher. She taught the shortcuts. She taught how to get the problem right. But at the end, you didn't really know what you were doing. You know, it was like, oh, the square root of 81, oh, it's 9, because it's 9. Well, why is it 9? I don't know. It's the square root of 81 is 9. X squared plus 2x plus 1. Okay, so we're going to figure this out by guesstimation. We're going to guess. We need to, you know, guess all this stuff that goes into this, and I was totally confused. We're going to guess numbers and try to make magic come out of this, and there was no steps that were just, well, let's see, we're going to put plus and plus because these are plus and this is plus, but we're going to try to make numbers here and try. And it's a method that's taught today, but this is the only method I knew, and that's called trial and error. And I was just like, and I remember when I first learned quadratic, and this is Algebra 1. I was in Algebra 1 in 1980. Seven? Let's say 88, just to be safe. 88. So we're talking 1988. Okay. But I could take the calculator and I could graph this and say, oh, look, here's this parabola on this graphic calculator. And here's where this isn't exactly, but there's a 0 at 1. I'm a terrible artist. And there's a 0 at, oh no, actually this one would look like this. I'm sorry. I'd graph it on the calculator, and that's all this thing would do was show out graphs, and it wasn't even very good at it. But you could say, oh wait, this is 0 when x equals 1, and well, actually this would be minus. Okay, we'll change this to minus just to match my graph here. But anyway, the point isn't the problem. The point is how I solved the problem. I looked at the graph and I could figure out the difference here. And then right after the Ti-81 came out, the Ti-85 came out, and I had to have it. And I had a job, and I was like, I'm buying that calculator. I want to save all my money up. And it was different. It was completely different. The Ti-85 to the Ti-81 was so different to the point where when the math teacher that was taking me to these conferences to explain how to use this calculator, and she would be giving me teacher guides, like instruction books with problems, and it'd say, hey, figure it out so we can go and do this. And I said, well, you know what, I'm not going to use that Ti-81 anymore. I'm going to use the Ti-85. Okay, so I used the Ti-85 for a while, and then my junior year in high school, I met a person that I still talk to this day that said that looked at it all funny when we said, hey, what's the square root of 40? And we were like, I don't know, what is the square root of 40? Well, this is Algebra 1, what's the square root of 40? He was baffled that we couldn't tell him that the square root of 40 was 2 square roots of 10, and he had to go back to Algebra 2 and reteach us Algebra 2. And this man is still a part of my life, and he is the kindergarten cop. He is one of the I want to write his name here. Kimball. I can't spell. Kimball. Paul Kimball is his name, and he teaches in, I don't even remember where he teaches. He teaches in Eagle Pass. So if you're ever privileged to go to college in Eagle Pass, and I can't remember the name of his university off the top of his head, I'm sorry. He teaches in Eagle Pass, and he is one of the reasons why I'm as good at math as I am today, because he taught me why. Why do we do square root of 40? Why don't we just put, why don't we just do this? Square root of 40. Why isn't the square root of 40 6.32456? Why isn't it that? Well, because the square root of 40 actually goes on and on and on and on. And I had him for pre-cal, This was in 1991. I graduated in 93. I took calculus. You can't see that. Calculus. We called it calculus. It was AP calculus. Paul Kimball, big part. I still talk to this man today. I call him Mad Dog. Whenever I send him problems, I call him Mad Dog problems. And we challenge each other with this. And some of the problems that we do that I call Mad Dog problems are going to come as a part of this video series. So Paul Kimball, a great part of my life, taught me many things. So then I went in the military, and I did 10 years in the Navy. And Veterans Day is coming up, so I did 10 years in the Navy. And 50% of those years, I was an instructor. And I taught math. And I taught basic math. But that's where I decided, hey, you know what? I need to be a teacher. And that's what I'm going to do, because I can sit there and I can explain to you how to do a problem. And if you are motivated to learn, you will learn. And I had a class of 5. 5 people were in my class, and 4 people wanted to learn. So it's not really hard to decide to figure out how many people passed. 1 person failed because he did not want to learn. The 4 people that paid attention did exactly as I asked them to do. And it's not a power thing. It's a, hey, look, go home and practice. Go home and study. You can't just watch me and learn. You have to go home and practice by yourself. And those people that did that and that came to school, I call it work because I was in the Navy, but came to school and worked, actually passed the class, were the people that failed. So what we actually did, this was actually a self-paced class, and they actually turned it into a instructor-led class because so many people were having problems with it. So and most of it was basic adding fractions and a little bit of logarithms, and everybody that was ever in my class when I taught that wanted to learn and wanted to pass and did what they were asked were passed. And that has been my experience ever since I started teaching and to this time. And 50% of the battle is desire to learn. You can't just watch videos and expect miracles. You have to sit down and you have to take notes, and you have to study those notes, and unless you're just gifted and someone said, hey, bing, and you figure it out, those people are the people you don't see. But then there's 50% of it, and those people that are like that, they want to learn it, and they learn it, ding, psh, okay. 50% of it is desire, and the other 50% of it is practice. You have to want to. And people keep telling me, how come you are so good at math? How come you're so good at math? It's not that I'm just a great person at math. It's that I practice and I study, and practice and study make a lot of it. Okay, if it's just like football. You think the professional football players out there, right there, you think those guys just go home and eat Cheetos and play Xbox and that's it? No, they run, they lift weights, they have a routine where they do so much a day. They don't do it all the time. Well, some of them do, but they don't do it all the time. But they at least set aside a time to do it. You need to have a desire, and you need to practice what you're doing. And if you do that, then you can get to where I was in college. And I feel bad for the people that were in my calculus classes because I already knew it. I mean, I was teaching math, and I had been in the Navy for 10 years, and I went to college, and I went straight to Calculus 1, and I went to the first day they had I guess the orientation, that's what you call it, and you go in there and they decide, hey, we're going to put you in this class and we're going to put you in this class, and they said, hey, I'm going to put you in Calculus 1, but I think you're a risk because, whatever. And I was like, well, I clept it. Here's the deal. I went to college in 2005. I took the AP Calculus class. I took the AP Calculus test. I scored a 4. Nobody scored a 5, I don't think, in my class. I could be wrong, but I scored a 4 on the AP Calculus test. And I clept AP Calculus, and I told them I'm pretty good at calculus. I'm pretty sure I know what I'm doing. Can you let me waive pre-calculus and college algebra and go right into calculus? And they were like, well, I don't know. Maybe. So anyway, they let me do it, and I got 100. I got 100 on every test in calculus 1 and calculus 2. And I drove everybody crazy because I would correct the teacher nicely, and I would challenge, they had this, we went to the lab, and they're like, we're going to learn how to do calculus on the computer, and they showed us this program, and I'm like, well, I have Maple. I was using Maple. I was using a TI. Again, the TI. I had a TI. Let's go to the TI Titanium. I didn't have a Titanium, but I had a TI-89. And I told my teacher, I said, there is nothing that your computer can't do that the TI-89 can do. And I was right. And so they made this hard quiz, and I still have it somewhere around here. It was like 12 problems of these hard super integrals, and I said, I'm not going to use your program. I'm going to go and do the same thing on my TI-89 and show you everything I can do. And they're like, well, you can't print it. I was like, well, yeah, I can, because it has a USB port and I can plug it into my... Okay. So the TI-89 was the next calculator after the TI-85. I had a TI-85, and it did calculus. It didn't... You couldn't say, hey, find the derivative of x squared plus 2 and go, oh, 2x. Okay, it couldn't do that. But it could say, hey, find the derivative of x squared plus 2 at x equals 1. That's what the TI-85 could do. Okay, and it could graph the derivative, which was great for optimization problems and that kind of thing. But the TI-89 would actually give you everything you ever want to know. It would say it's almost, the TI-89 is almost as powerful as this baby. It's not as powerful as this baby, but look, this guy's in color. Color. And there's things on this that I still haven't figured out how to do, just because I haven't had the desire to sit down and do it. But I've linked where you can buy this calculator, and I strongly recommend. This is the only thing in any of my videos that I will ever endorse, is you don't need the CAS. The CAS means that you can plug it into your computer and do it here. Okay, the Ti-Nspire CX. You may not even need the CX. Either of these calculators. This calculator will do everything that you will ever need to do throughout most of the lectures in my class that we're going to go through. I say class, but I mean lectures. Okay, so I went to college, and while I was in college, I met my second mentor, and I have to mention him because Mr. Kimball taught me a lot about math, and I used his strategy throughout all my teaching. I pretty much tried to emulate him, of course, because he meant a lot to me. But then I met the man's name is Herman Donnell Cole, and he has since retired. But this man he didn't just teach me math, he taught me how to teach myself math. When he was in school, and I strongly agree with this method. If you are, and I hate to use, and the teachers use this, the weed out method. Oh, this is where you weed people out. Well, you can't figure this out. Well, you're never going to make it. Or this is the weed out class. If you don't get through this one, you're never going to get, you need to change your major. But, and that's what these guys were talking about. But this is at the PhD level. But I use this method, and this man passed away, but he taught this man using this method. It's called the Moore method. And I would say I use this method 1/4 of my math classes. In college, because a lot of my math classes in college, my professor, Herman Donnell Cole, he was an adjunct, and they would allow him to teach self-study classes. To the point where I took so many from him, the point where the university was paying him, he wanted to pay me back. And I said, no, I paid him, and they paid. It was crazy, but I was on the GI Bill, and I was on, because I'm a veteran, and then I was later on the Hazelwood Act, and I said, no, I'm not paying for this, and you're not, we're just going to learn together. But the classes were just me and him, and he never once, not once in any of these classes, got up and lectured the class. It was me lecturing him, and of course everything I did when I was up there teaching, it was teaching me how to be a teacher at the same time. It was the best, not a teacher, maybe a professor, because we were doing some really high level. I did complex analysis with him. Complex analysis. I did. What else did I do? I did partial DE, and I did another class, I can't remember. But it was these classes that taught me more math than I will ever know, because I was the one with the chalkboard. I had to go home and prepare the lecture. So I'd prepare a lecture. I said, today we're going to do section 111.4 out of so-and-so book, and it was that method, and that it was a real method. And especially at the PhD level, it was like, well, I want you to go home and read these papers and then tell me about it. And that method works. It doesn't work for everyone. It works for people who are motivated. Okay, so we did that. So those are the two influential people, and I'm going to give them credit in my journey. The two influential people on my journey are Paul Kimball, the kindergarten cop. If you've ever seen Kindergarten Cop with Arnold Schwarzenegger, kindergarten cop's name is Paul Kimball. So Paul Kimball and Herman Donnell Cole. Okay, so, and then I graduated college. I taught 2 years at Memorial High School. I met my arch nemesis, the evil department head, and that ended my high school career. That ended my teaching career. I no longer teach professionally. I have a tutoring website where I tutor people, and I now have this website where I am discussing my journey in math, but I'm not going to give my arch nemesis credit. But she ended me, and my best buddy quoted me. She goes, "She's going to end you. Whatever you do, there's nothing you can do." And I was like, man, I'm good at math. I can do whatever. And, if you don't get along with your boss, you're done in any business. I don't play politics. I was never good at politics. I was just good at math. So, let's start. Enough of this stuff. Let's talk about where we're going to go. So, there's a link below to where you buy my calculator. And when I do math, I have my calculator and my pen. I use a pen. I strongly recommend that you use a pencil because you can erase and save paper. I use a pen for two reasons. One, you can read it on the camera. Two, it's smooth to write. And I say that because if you look closely at my hand, I'm 50% disabled in my right hand, so I can't write very well. So if I write sloppy, I apologize in advance. But I still try very hard to write very neat, but I'm 50% disabled in my right hand. I can bend all these, but I can't bend this one at all. So I use a pen. You should use a pencil. I strongly suggest that when you watch videos, you should pause and do problems that I do. When I write, hey, okay, we're going to do this. 1 plus 1. You should hit pause before I go 2. Okay? You should hit pause and try it yourself. If you don't have the initiative to press pause and try the problems that I do before I hit 2, before I write the answer, then you need to figure out what you're going to do. Because if you're trying to pass a class, you need to get involved and you need to study. Okay, so let's practice this. Here's 3 plus 5. Press pause and I'll show you the answer. There you go. Okay, all you have to do is press pause, figure it out yourself. 8. Now, if you already know what 3 plus 5 is, then you don't have to press pause, but there's going to be a place eventually in my journey in math, I hope, and if there's not, then you don't need to be watching my videos, but where you need to press pause, try the problem yourself. It's on YouTube. You can press pause. There's a pause button at the bottom. It's right here. Looks like this. Press pause, okay, and try the problem by yourself before I tackle it. So let's go on to where my journey is going to go. I'm going to split this journey up. I'm going to treat it like a TV show into different seasons. And I believe that math is sequential. Sequential. And the problem with a lot of people in math is they learn. Okay, let's say this. Everybody knows the ABC song. A, B, C, D, E, F, right? Okay, so, and it's Twinkle Twinkle Star with the ABCs, in case you didn't know. But let's say, let's try starting to sing that song at F. Just try starting at F and try to naturally sing the song. It's much more difficult than it is if you start at A. Math is sequential. If you don't know A, then you can't start a class at F. That's my point. If you're watching the video later down the road and you're at part 40 or whatever, episode 40, and you haven't watched episode 20, you're going to have some problems because math is sequential. You need to learn A before you learn F. So let's start where we're going to learn. There's a lot of basics. The first episode I call Series 1. That will be the next video This will be part of Series 1, but Season 1 is arithmetic, where we're going to learn add, subtract, multiply, divide. Add, subtract, multiply, divide. And you're going to later learn that all of these is really add. Okay, let me explain that real quick. And this is something that my mentor, Donnell Cole, enforced on me, and I'm a firm believer of this. If you can't add, you can't subtract, you can't multiply, and you can't divide. So you need to learn how to add. Why? Subtraction is the inverse of addition. Subtraction is the inverse of addition. So when you say 3 minus 2, you are really adding -2, which is something that we're going to learn later in this part of arithmetic. Okay, so subtraction is the inverse of addition. Multiplication is repeated addition. Multiplication is repeated addition. So if you can't add, you can't multiply. So you must first learn how to add. If you can add, then you can multiply. Division, we're going to learn, is the inverse of multiplication. So if division is repeated addition, division is repeated subtraction. Division is repeated subtraction. Exponents are repeated multiplication. Repeated multiplication. Exponents are repeated multiplication. That means roots are repeated division in some way, which roots are repeated subtraction, which means roots are addition. And you will learn later, much later when we get into calculus, that the square root of a number is actually a sum of things. And we're going to get into that much later. There's only one operation in math, addition. If you learn addition, you can subtract, because subtract is the opposite of addition. You can multiply, because multiplication is repeated addition. You can divide, because division is repeated subtraction. And exponents are repeated multiplication. So that means exponents are repeated addition. Okay? So that's part of arithmetic, Season 1. Arithmetic. Okay? So Season 1, arithmetic. But there's different types of numbers that we're going to look at in arithmetic. The first, we're going to start with whole numbers, of course. Whole numbers, numbers that don't have parts. 1, 2, 3, 4, whole numbers. Then we're going to do the same thing that we learned with arithmetic with fractions, or parts of whole numbers. Okay? And then we're going to take the same thing that we do with fractions, which is almost similar to what we do, but we call them decimals. Decimals and fractions are parts of whole numbers. And then we're going to learn a different notation, which is percent. And percent is just a shortcut to make it easier for your brain to handle fractions and decimals. And then we're going to look at negative numbers. And Einstein said that his main problem with math is negative numbers. The man who developed atomic theory had problems with negative numbers. So don't feel bad if you have problems with negative numbers. So Season 1, arithmetic. Then we're going to get into algebra. Algebra is the next season. So after we do a complete lectures of some lectures of arithmetic, we're going to look at algebra. And guess what? Algebra has the same kind of deal. We're going to start with whole equations. That's the best way to put it. Equations without fractions. Then we're going to look at rational equations, which is just like what we did here. We start with whole equations, like 3x plus 4 equals 1. That's a whole equation. A rational equation would be 3x plus 4 divided by x is equal to 1. And then we're going to do problems with percent, most likely. And then we're going to look at quadratic equations. And that's algebra. What is algebra? Algebra is finding no, it's not finding. I'm sorry. Algebra is hard to explain. Algebra is introducing variables and manipulating things with variables. That is algebra. That's my definition of algebra. If you go look it up in Webster, you're going to see something different. Season 3, trig. Trigonometry. Trigonometry. This is the triangle functions and those buttons that my dad couldn't tell me about. The sin, the cos, the tan. And all they are ratios. They're fractions. So you have to understand fractions before you understand trigonometry. And then how the triangle translates to the circle and where that comes into. That's season 3. Season 4. Where are we going from there? Back to algebra. Back to algebra. So the first one's kind of like the introduction to algebra. And then we're going to learn some trig. And then we're going to learn some more algebra because we can use some of this algebra that we learned from trig. And in most college classes they call it pre-cal, where they combine the two. But I think they should be different. I think that algebra and college level algebra and trigonometry are two courses. If they're taught right, you get those two. You don't need pre-calculus. Season 5 is calculus. And I want to split it into single variable and multiple variable. This is a lot of math. A lot of math. So this would be season 5 and season 6. After calculus, we're going to learn linear algebra. Another algebra. So we go back. You understand how important algebra is. The hardest part in math isn't calculus. People aren't still... Calculus is what's called closed. Okay? There's even another algebra after linear algebra, which I don't know that I'm going to do or not, which is modern algebra. And then there's other algebras. Algebras of algebras of algebras, and that's just too much. So calculus is pretty much closed. Closed means they've discovered about everything they can about calculus. They haven't, and they probably never will, discover everything they can about algebra. A computer can solve this. What a computer does is it's so fast that it can try every single digit number out to fucking 9,000 places. They can figure it out up to 9,000 places. What makes this true? But how to solve this is an algebra that we don't know yet without a computer. This is what using a computer would be numeric. Okay. And you can use calculus and a method called Newton's method to solve this. but there is no way so far that we can find an exact number. And you're going to learn that there's a number called an exact number. And I'll give you an example. Square root of 40, look at my calculator. Square root of 40 is an exact number. 6.32456 is not an exact number. And actually square root of 40 is a bad example of that, because if I type square root of 40 on my calculator, I'll show you what comes up. That 2 squared is 10 I was talking to you about. This is an exact form. This is not exact. This is what a computer would give you trying to solve this. Okay. What we're looking for is an exact formula that says, hey, what is this? And that is, not too many people are working on it, because where would you ever need to solve this? But it's part of math that is not closed, where calculus is closed. Okay? So linear algebra is equations of this form, which look pretty easy. But A can be infinitely many equations with infinitely many variables Okay, so let me show you an example of what I mean of AX equals B. So AX equals B looks very easy. It looks very simple. However, if A is this matrix, and B is a vector, and B is only, and B looks like this, there's a lot of different possibilities here. There's one solution, or there's two solutions, or there's infinitely many solutions. There's either one solution, there's either no solution, and there's infinitely many solutions. This is linear algebra. Okay, so linear algebra is a possible season 7. I can't discuss my journey in math, and I took linear. No, I never took linear algebra in college. I can't discuss math without discussing differential equations, which is my favorite subject in math. Differential equations. And I will tell you what differential equations is. It's the answer to where will I use this. If you're in Algebra 2 and you're doing anything in Algebra 2, or if you're in Calculus 1, or if you're in Calculus 2, and possibly in Calculus 3, and your question is, where will I use this? The answer is differential equations, which is season 8. Okay. And that's way down the road. And there's also calculus linear algebra, where A is a variable. A is a matrix of variables. X is a vector. X is a vector of variables. That's a differential. I guess we could call it this. AX equals X. This is probably some of the hardest stuff that we will solve in my journey. Unless we go on to season 9, which is partial differential equations, which get a little bit harder. But along the way, we're going to discuss series, Taylor series, lots of different things. Those are all in my journey. So, In conclusion, I am looking forward to starting from the beginning. There's a lot of scary stuff in this video, but I plan on starting at A, and I plan on taking you to Z, where A is nothing and Z is almost everything, infinity. And I hope you go along for the ride, and I really am looking forward to this, and I'm trying to, I have some courses set up where you can pay and do some problems online, and it'll grade you, and I'm not sure I'm going to incorporate this yet unless you put in the comments, hey, I want this. I want to be able to do some problems and take tests and treat this as a class where I won't get credit. You won't get college credit for this, but you'll get accomplishment, which is important to me. So I look forward to seeing you in the next lecture. This has been a great time, and I hope to hear your comments, your questions. If there's a whole bunch, I can't answer all of them, but I will try to get as many as I can. My website for private tutoring, I still have private tutoring. Let me put that on here. I am the CEO of Mathspace Tutoring. It's at www.facebook.com/Mathspace Tutoring. We can get I have a virtual classroom with WizIQ.com. I try not to talk a lot about these people because I don't really deal business with them anymore, but I still have access to their site, and that's where I would have a virtual classroom to do. So try to set up an account with them, and that's it. As far as I'm concerned, I wouldn't do anything else with them unless I asked you to. But that's just the way I am, because that's the way these people have been with me. Okay, so this is the website, mathspacetutoring.com. Send me a message, drop me a Facebook on my wall if you need private tutoring. My rates, I charge $20 an hour for tutoring. I do groups. If you have a group that want to learn, I have a group rate. We'll discuss that. It's case-by-case basis. But I'm not here to advertise my tutoring. I'm here to teach math, and we'll do that in the next lecture when we start with arithmetic in Season 1. I appreciate you watching, and we will see you soon. Subscribe for future updates of this channel, and like this video if you enjoyed watching it and my history of math. Thanks.